Okay, so let's head to the last examples. And in this case, you have a satellite propelled 3 kilometers from the Earth's atmosphere, and it is required 3.78 times 10 to the 6 Newton of force to determine the work done for this propulsion. So neglect the air resistance and weight of the propellant. Take the radius of the Earth as 6371 kilometers. You can visualize the Earth as if meron kayong bilog, okay? And then, of course, 6371 yung radius ng ating Earth. So, from the center point, you have 6371 distance. Gawin natin medyo diagonal. Okay, so that is 6371 kilometers. Okay? And then, you're propelled, sabi dito, you're propelled from the atmosphere. So, i-consider natin na yung atmosphere is, hindi na rin siya ganun ka layo with 6371. Ina-neglect na natin yung distance na yun. So, that is 3 kilometers. So, technically, that is from this point, you have 3 kilometers. So, pinropel ka ng 3 kilometers. Though not to scale this one. So, ito na yun. Ikaw na yun, astronaut. So, technically, ito ha, alam naman natin yung atmosphere is some distance pa from the ground. So technically, the radius of the Earth is measured from the center point going to that upper ground. So not considering the atmosphere. So if you would like to consider that, syempre mas malaki pa yan. Pero we'll just neglect that and just consider 637 on being yung sa whole Earth na. So with that being said, they have 3 kilometers. Technically, yun yung distance mo from the parang surface or the atmosphere. So sabi dito, it required 3.78 times 10 to the 6 Newton of force para ma-propel ka. So, kung ganun, 3.78 times 10. So, we have the force that is equal to 3.78 times 10 to the, forgot, ano ba yun? 6. 6. Okay. So, we also have to neglect syempre mga air resistances natin. So if this is the force being used, remember the force can be related in terms of G, M1, M2, and then ano pa ba yun? We have R squared, or the distance between these two bodies. But just to give you an information, if we do not know kung ano ba yung ating mass ng Earth, though it's still possible to determine it by simply searching, no? Assuming na hindi natin alam, and we're only given with this expression, does it necessarily mean na kailangan pa ba nating hanapin yun? So, actually, hindi na. Kasi, if you're given with the force, that's 3.78 times 10 to the 6, and, well, G can be determined kasi parang, naman siya, constant. But, it's no longer necessary kasi, remember, this G, and then M1, M2, and then R squared. So, kapag ginamit natin to in terms of the expression of the force or the work, so, diba, you already know the value of your R. So, hindi to R sub 2, R squared. Now, from this, remember, the weight is directly proportional to the distance from the surface of the Earth. So, as we move further away from the surface of the Earth, we could just think of our weight being decreasing, diba? So, we have this force, 3.78 times 10 to the 6, and remember, if you want to determine this force, from the initial point, we could say that that is 3.78 times 10 to the 6, that is equal to G M1 M2 multiplied by R squared, and in this case, since it is in the initial position, we have 6371 times 10 cubed squared being our initial distance or the location. Kasi diba, we start with the surface. So in this case, it is simply the radius of the Earth squared. So therefore, G M sub 1 M sub 2 is equal to 1.5342 times 10 to the 20. And then the unit here is in, of course, that is force, that's Newton, and then meter squared. So Newton meter squared is the unit. What happens with the equation of the work? So the work is simply the equation from the lower limit, that's 6371 and then 6374, and then ano ba yung F mo dito? So F is GM1 M2 over R squared, so that's 1.5342 times 10 to the 20 divided by r squared, and then you incorporate dr. So hindi na siya x kundi r kasi we're talking about the radial distance from the center to the outer space in this case. And 6371 here is used rather than 0 kasi we're considering muna, una is that yung mathematical incorporation natin ng r squared being at the denominator. So kapag in-integrate natin, maging 1 over r, which in this case kapag 0 will be undefined. So hindi yun pwede. Pangalawa is that we're starting with the center, considering na yung ating weight is very dependent on the distance from the center to the surface, and then to whatever end distance is the material located. Kaya we start with the surface of the earth. So, or the distance of the surface of the earth from the center. So, yan. And then the work, this gives you the value that is equal to 1.1335 times 10 to the 13. Okay? So, yan, to the 13. So, that is your unit. And remember, since this is in Newton meter squared, and then you divide this by kilometers, kasi diba this one is in meter squared, and then pag na-integrate to, maging kilometer na yon. So, technically, the final answer would be something like this. No? Meron kang Newton meter squared, and then yung r squared natin, in-integrate natin. So, the negative 1 na yung kakalabasan niya, which in turn becomes per kilometer. So, therefore, by converting all of this, kasi diba, this is something like Newton meter squared divided by 1,000, so something like this. So, therefore, your work would be 1.1335 times 10 to the 10. So, that would be your, unit, or your exponent, then Newton. Kasi, that is Newton meter squared per kilometer. Kasi, again, this Newton meter squared came from the value of your GM1, M2, the unit NM squared, and then yung R squared mo is, diba, yung R mo is in terms of kilometer. And remember, since upon integration, maging R to the negative 1 na yan, so therefore, kilometer na lang yan, hindi na siya kilometer squared. So therefore, NM squared over 1,000 would give you the cancellation of NM squared over M, which leaves you the Newton meter, which is actually in joules. Okay, sorry, ba't ba Newton to? So this is in joules. Okay, so therefore the answer is 1.1335 times 10 to the 10 joule. So in your handout, the answer is in 11.3347. So that's 11.33. Okay. So it's 4 decimal places. Okay. So yun, pero it's just the same value kasi gigajoule to. So diba, gigajoule is 10 to the 9. So therefore 10 to the 9 plus 1 would be 10 to the 10. That's why it makes sense that it is the answer. Okay, so that is for the propulsion. Hopefully, ay mag-guess siya. So, meron dyan number 11. Hopefully, masagutan niyo siya. Yun yung isa natin na application. Though, ito naman is napaka-basic lang din. Same concept lang din. Meron lang kayong given M1, M2 instead na wala siya. And then, meron ding G. So, unlike dun sa kanina na wala, so ito ngayon, lalagay nyo na sila ng values. Okay, and then you'll be getting the constant. Ganon. So, initial distance muna tayo lagi. Okay, and finally, number 12. So, last na nga ba talaga to? Okay, so that's the last problem for the application. Di ba pala? Kasi application 2, tapos ito yung part 1 pala ng application 2. So, determine the work required to move a positive charge. So, nasa columns na tayo, no? 9.21 times 10 to the negative 6 from 0.31 to 37 with respect to a stationary charge 3.77 to 6 negative 6 coulomb at 3 negative 1. Take 1 unit, the coordinate is equal to 1 meter. Okay. So, let's do a Cartesian coordinate plane. So, ito usually yung ginagawa natin pag meron tayong mga columns law and we're dealing with charges. Gagawa tayo ng Cartesian coordinate plane just to see where these charges are located. So, 3, 1. So, 1, 2, 3, 1. This is where the first charge is located. From point 3, 1, ito yung initial location niya. So, going to 3, 1, 1, 2, 3, 4, 5, 6, 7. So, umakyat tong charge na to. So, we could just write 9.21 times 10 to the negative 6 coulomb, and then it went to that point. So, with respect to a stationary charge of 3.70 and then the negative 6, So that's -1. So it's around here, yung isang stationary point, and then that's 3.76 times 10 to the -6. Okay. So the question is, ano ba yung distance nito or the work that is being carried out, assuming na we're related to the stationary point here. So ito yung stationary point natin. And this one is the moving point. So, this is just a very simple problem in terms of charges, no? Diba sabi natin that work is always the integral from a to b f of x dx. And in this case, since we're dealing with charges, the work is related to k and then q1, q2 over r squared. And remember, your k is actually the Coulomb's constant, and that's 9 times 10 to the 9. So therefore, F is equal to 9 times 10 to the 9, and then charges Q1, Q2, and which is actually a constant, R squared. So we can just incorporate na pala dito yung Q1 and Q2. So that is 9.21 times 10 to the -6, and then 3.76 times 10 to the -6 coulomb. So F would be equal to, so that is 0.31166664. So going back to the unit of your Coulomb's constant, so it's right here. The unit is Newton meter squared per Coulomb squared. So therefore, upon multiplication with Coulomb squared, so you'll be left out with Newton meter squared divided by R squared. Okay, and then going back to this equation, so we have the work that is equal to, ano ba yung position niya from the first part going to the latter part. So diba, it starts with this 3, 1 and then end up with 3, 7. So therefore, ano ba yung, gaano ba kalayo siya? So you can just incorporate dito 1 to 7, or you could just have 0 to 6. Pero it's better na we use 1 to 7 kasi that's yun naman nakalagay sa ating coordinates. So 1 to 7, and then what happens next? So ano ba ating f of x? So this is your f, so 0.31166664 Newton meter squared per r squared. But remember, this r squared is the distance from the 2 points that you have. But then again, remember, yung distance natin between these 2 points would always be something like, diba? This one is 7 units. We know now na 7 units, and this one is actually 1 unit. So as I move from this point, as I move away from 1 to 7, so I'm approaching 7, but then again, that's always an additional y value. So that's 1 unit, or parang ano siya, plus 1 unit lagi natin. So parang 1 meter kasi ano dito yung 1 meter. So therefore, in this case, yung ating distance would always be something like y plus 1. Kasi diba, this is 1 unit and then this is always your y. So parang lagi siyang may y plus 1. So therefore, the distance or r would always be parang y plus 1. Okay, and then the change would be dy. So therefore, we could just say that we can relate this expression in terms of w is equal to the integral from 1 to 7 and 0.31166664 divided by, ano ba yung ating r, that's y plus 1 squared, and then ano ba yung dr natin, so dr is equal to dy, so that is dy. So therefore, the work would be equal to the integral, and that is 0.1168 joules. Joule lang pala kasi wala pang 1. So yun, that is how you solve for the work that is required to move a certain charge in a certain point. So that is very easy kasi, as you can see it from the figure naman, that's just y plus 1 distance from from the stationary point. But remember, what if the stationary point was located somewhere here? So, kung ilang units to, ipa-plus sila sa y. And kapag yung point naman is located somewhere here, syempre, pag mas lalapit siya dun sa point na yon, so technically, mas minus yung ating distance kasi papalapit na siya. So, yun yung concept naman ng ating moving charges when it comes to work. Okay, so I think that ends the application of integration for the first part. Okay, so we have the second part pa dito. Let me just check. Actually, it has kasi 3 parts yung ating application 2. So, let's deal with all of them. Hopefully, tapos natin ito lahat. So, let me talk about muna yung moments, centers, mass, and centroids before we deal with problem solving.